So next year, class 10 science, chapter 2, acids, bases and salts. Okay, the next test portion 2C, this will cover from question 31 to 56 on your tuition note, pages 49 to 56. Okay, this portion will be covered by videos 5 and 6. Let us do the video 5. This portion, video 5, will cover test 2C portion from question 31 to 44. Okay, so here let us start with the first question. Why must hydrogen ion always be shown as H plus AQ and not only H plus alone? Or if you don't want to do that, then why should we write H3O plus, meaning hydronium ion? If you don't want to put AQ, then you must write H3O plus. Why? This is the reason here. See, hydrogen ion cannot exist alone. That means H plus cannot be H plus like that on its own. But they will come into existence only after combining with water molecules when you dissolve the acid in water. Okay, in simple terms, you pause the video and write all this portion and replay. Okay, next year, in other words, H plus will exist like this. Once it cannot exist on its own like this. Okay, it has to come and combine with water and form this H plus H2 H3, and then here O means plus here hydronium ion. So since H plus will have to combine with water to form hydronium ion, we have to express it as H3O plus. Or if we don't want to do that, then we must write AQ at the back of H plus, indicating that H plus is dissolved in water. Because H plus dissolved in water and H3O are same, that means because H3O is formed when H plus is dissolved in water. So you can write this way, or H plus, not just like that, but AQ at the back. Let's just to remember that and understand properly, let us write down this one. Therefore, hydrogen ion must always be shown as like this. If you want to write H plus, then you must not forget to put AQ, meaning that we know that H plus cannot exist without water. AQ means water, aqueous, right? Next year, or if you don't want to write like this, then we must write like this. If we don't want to put AQ, H3O plus. Okay, so next question. What is neutralization? We've done this before also, but let us do once more. This is simply reaction of acid with base. So you can write acid plus base, or you can also write base plus acid. Doesn't matter, whichever way you want. Okay, to form salt always plus water usually. Okay, but sometimes we don't get water. Just generally putting it, we can also write it as HX representing the acid plus M here is the metal ion. Okay, MOH representing the base. So when they react, the first one is positive and second one is negative radical. So here the first one positive, second negative. So positive M metal will combine with this to form MX. So MX represents the salt here. And outside the box, HO plus H means H plus H, H2, and then O. So this represents salt, this represents acid. We can write in general form like this. Let us take some specific examples just to understand. One famous acid, HCl, combined with the famous base, sodium hydroxide. Then this negative and positive will combine, so you'll get, usually we write plus first, Na plus, and then Cl. This is the salt. And outside the box you see HO plus H, exactly balancing H2O. You can take one more if you want. HCl, same acid you can take. Another base, potassium hydroxide. So K positive and Cl minus combine to form the salt, KOH. Okay, and then outside the box H plus H, H2O. So these are two specific examples. So it's simply a reaction of any acid with base to give salt and water. Next here, define neutralization in terms of release of hydrogen ion by acid and hydroxide ion by base. We know now by now that one definition of acid is this: acid releases hydrogen ion, and we must not forget to put AQ in the back, acknowledging that H plus cannot exist alone, but in water only. And we know the definition of bases they release. Bases is that bases releases hydroxide ion, and we must acknowledge that it is possible only in water by putting AQ. So this H plus imparts or gives the acidic character, or OH minus, sorry, here OH minus imparts the basic character. In other words, without the release of H plus, acid behavior will not come out. It's not an acid. Or without releasing OH minus, the base cannot impart the basic character. Means acidic character comes from H plus, basic character comes from hydroxide ion OH minus in water. So neutralization can also be defined as the reaction of hydrogen ion, and we know the symbol is H plus AQ, with hydroxide ion. We know the symbol is OH minus at the back, AQ. So many textbook, in many places they will represent acid, means they'll just represent by H plus AQ, and this is enough to represent an acid. So we can say neutralization is reaction of hydrogen ion with hydroxide ion, of course in aqueous condition, to give you the water molecule. Okay, so this is the base. So it is the reaction of hydrogen ion with hydroxide ion. We can say like that also, because hydrogen ion represent acid and hydroxide ion represent base. So that is how we can define neutralization in terms of hydrogen ion and hydroxide ion representing base. Okay, so that is our answer. Okay, so this is H2O. If you want to put liquid, if you forget also, that's okay. Everybody knows that H2O is liquid. Next question, very important but quite simple if you listen carefully. You pause the video and draw, okay, this one, and replay after you draw it. What is acid base dilution? So we're going to understand what is dilution, and when is, and this is not AND, when is an acid or base said to be diluted? Means what must you do so that we can say the acid is diluted, like that we can say what is the condition. Okay, let us take acid. Let us say HCl, hydrogen chloride dissolved in water, hydrochloric acid. Here in 1 liter of water, this one 1L represents 1 liter of pure water. This is not true picture, okay, but just for understanding it's quite good. Let us say there are 4 hydrogen ions, 1 2 3 4. There will be millions actually, but to understand I just took 4. Okay, there are 4 hydrogen ions inside 1 liter of water. So that means the hydrogen ion concentration means how much hydrogen ion is there is called concentration. Here in the first picture is, picture 1 is, there are 4 hydrogen ions per liter. So in 1 liter, that means 1 here, 1 is there. So now what do? You next add 1 more liter and make it 2 liter. So let us say the ions spread uniformly. So in 1 liter now, the water has increased to 2 liter, but hydrogen ion has not increased, no. So it will be, in just 1 liter portion, there will now be only 2 hydrogen ions. So from 4 per liter, 4 hydrogen ion per liter, to in 1 liter, there are only 2. So the hydrogen ion concentration in the second picture is only 2 hydrogen ion per liter. That means concentration is reduced to half. 4 here, 2. So this process of decreasing the hydrogen ion concentration by increasing the volume of water is called dilution. Okay, and when you have done this process, this is called, the acid is said to be diluted, or the base is said to be diluted. So for same thing here, you can take the base also. Here 4 hydroxide ion are there in 1 liter of water. So concentration of hydroxide ion is 4 OH minus per liter. But add 1 more liter of water, but don't add any base. And let us say they spread uniformly, then in 1 liter there will be only 2 hydroxide ions. So concentration is reduced. So the process of reducing the hydrogen ion or hydroxide ion concentration by adding more water is called dilution. Okay, dilution. So let us go to the next question. Number 43 is related to this. So how is the concentration of hydronium ion, H3O plus or H plus also you can say, affected when a solution of an acid is, hydrogen ion means hydronium ion only. So when solution of an acid is diluted, means Diluted means water is added. So when you add water, hydrogen ion concentration decrease means, that means hydrogen ion decrease, because hydrogen and hydrogen are same meaning. So you will say, how is it affected when you dilute? The H3O plus means hydrogen ion concentration will decrease when you dilute. Means the word dilute means add water. You can see that from this picture, previous picture that you've done just now. Next question is opposite of this one. These are all textbook questions, okay? Question number 5, textbook, page 26. Then question 44, tuition note, but question 6 on textbook, page 26. How is the concentration of hydroxide ion, means OH minus, affected when excess base is dissolved in a solution of sodium hydroxide? Now here, when it is diluted, it will decrease because water is added. But when you put excess base, means extra sodium hydroxide, then only 4 hydroxide ion are there. Now you put some more 2 grams of sodium hydroxide, then the hydroxide ion will increase na, per liter also. So your answer is hydroxide ion AQ concentration will increase because excess is added base, means concentration of the hydroxide ion will increase. Diluted, then more water is added, so concentration of hydrogen ion will decrease. Right? Simple questions. Now go to the next question, question 39. This is question 4 on textbook, page 26. While diluting means, please remember, always dilute means adding water. Like you're taking orange squash juice and it's too strong, then you put water to make it thinner. That's called diluting, adding water to decrease the concentration of orange in the squash, right? While diluting an acid, why is it recommended that acid should be added to water? Acid to water and not water to acid. Very important. When you add water to acid, what happens? This one, number 1, this reaction, mixing acid and water, is exothermic, okay? Highly exothermic. That means highly exothermic means large amount of heat is released. And because of that, the acid splash means it will come out when you add and then go onto your shirt, your skin, and burn your skin and cause accident. But when you add the concentrated acid to the water, so to dilute, then that does not happen. The splashing does not happen. That's why always add the acid to the water. This is the correct way, and this is not recommended. Okay. So next question, question number 40. Why do HCl, means acid, nitric acid, hydrochloric acid, nitric acid, HNO3, etc., show acidic character in aqueous, means water solutions, while solutions like alcohol and glucose do not show acidic character in water? Okay. When you dissolve HNO3 in water, and this is now liquid, means it's in water, they release here you can see very clearly, H plus, and the cation, anion is NO3 minus, nitrate ion. And here hydrogen ion will be released by HCl, and then negative ion, anion is minus. So they release acids. You can tell me now, release what? Release cations and anions, especially hydrogen ion. They release hydrogen ion. That's why the reason is because they release hydrogen ion, which is the cation, they show acidic character, because the acidic character comes from the hydrogen ion. Then why do glucose and alcohol, they also contain hydrogen or not? Yes. Just like HNO3, there is HH here, HCl. Here also C6H12 glucose. There are so many hydrogen atoms. Here also so many hydrogen atoms. But they do not show acidic character. Why? Because they also contain H, means hydrogen atom, but do not release them as hydrogen ion. Why they do not release? Now, acids they release because they are ionic, means they are able to release ions. But here glucose and alcohol, they do not show acidic behavior. Even if they have hydrogen atoms, they do not release hydrogen ion because they are not ionic. They are not ionic substances, they are covalent. All covalent substances are those substances that do not have ions in them. Okay, that's the reason. Now next important question, 41, question note, question number 2, textbook, page 26. These are all textbook questions. Why does an aqueous solution of an acid conduct electricity? When you dissolve HCl in water and pass current, current will pass because the bulb will glow. So switch on and the current will pass. Why? Because when you dissolve the acid in water, even before the current pass, hydrogen ion and chloride ion will be released, for example, meaning cation and anions are released. Cations and anions, millions of them. I have shown only one, but there will be millions of cations and anions. And because this cation means positive ion, they are positive, they will go towards the negative terminal. This is the negative terminal of battery. Positive. Negative means come this side of the nail, see here. They will be attracted like a magnet to the negative terminal. And the negative ion, that is anion, will be attracted to the positive terminal of the battery. See, this is the positive. Because of the movement of this negative to positive terminal and the positive to negative, that movement is actually the current in the liquid. That's why they conduct electricity. Whereas if you put glucose and alcohol, they do not have ions, so there is no movement of ions in the liquid. So glucose and alcohol therefore do not conduct electricity because they do not have cations and anions to move, right? So that is the reason. Okay, now remember this: when you switch on the current always pass from positive side to the negative side. Okay, and outside though it's flow of electrons, but inside the liquid it is the flow of the ions. Okay, ions. Okay, so that is what we remember. The next question, 42: why does dry HCl gas not change the color of blue litmus paper? We know that acid change blue to red litmus, but when you pass HCl gas, which is supposed to be acid, they have no effect on the litmus paper. Why? Because acidic character is imparted only by H plus AQ ions, and this H plus AQ is released only in the presence of water. So if you pass it through dry blue litmus paper, the dry hydrogen chloride gas is also dry and the paper dry, so there is no water to cause the HCl to release H plus. So where there is no H plus, there will be no change in color blue to red, because the blue color changed to red because of the action of H plus, not because of HCl. Okay, but there is no water in them in the dry blue litmus paper, right? So that's why HCl gas is not able to release the H plus. Even though it contains H plus, it is not able to release it. And unreleased H plus ion have no effect on blue litmus paper. Okay, so that is your answer. So next, that is 42, and then let us go there. Okay, so up to 44, whatever we have done that. Now let us go through the ones where we have to do on our note here. 31 is done. We have discussed that just now. Why must hydrogen ion always be shown as H plus AQ or H plus H3O plus? That we have done. Next, 32 here. What are alkalis? Give an example. An alkali is a base that dissolves in water. So any base that dissolves in water is called alkali. And then example, sodium hydroxide, potassium hydroxide, magnesium hydroxide, ammonium hydroxide, calcium hydroxide. All these are bases and they dissolve in water, so they are called alkali. Question 33. All bases do not dissolve in water, but only these ones, this type dissolve. So all the alkalis are bases, we know that, but all bases cannot be alkali because all bases do not dissolve in water, isn't it? So just tick there yes. And then why is calcium chloride, we have discussed this before also, used as in the guard tube for drying? That means drying tube. To dry means to absorb the moisture water. Calcium chloride is a moisture absorbent, means water absorbent. It absorbs water. So it absorbs the moisture in the gases passed through it. Suppose you pass dry HCl gas, it will absorb all the moisture in the gas that is passing through it, helping the dry to dry the gases. So this uses a agent in the guard tube, because the guard tube is a drying tube. The purpose is to dry, right? We've discussed 35 already, neutralization, so we will not do that again. You can go through them now. Define neutralization in terms of release of hydrogen ion by acid and hydroxide ion by base. We have also discussed it. 37. What is acid-base dilution? When is an acid or a base said to be diluted? We have discussed that. You read through. I think you'll understand them very well. 38 now. 38 is the process of dissolving an acid or base in water exothermic or endothermic? Illustrated with an experiment. That also we have done. It is exothermic. Just read through yourself, okay? Though, or you can just read through once if you want. Here, add a few drops of concentrated H2SO4 to about 10 ml of water in a beaker, means container, glass container, and swirl means like this. You like cooling your tea, swirl it, shake it. That means gradually, slowly for some time. On touching the, now we go and touch the base of the beaker, we find that the temperature has increased. In the beginning it was cold, but when you mix the two and shake, the temperature is increased. After the acid and the water have been mixed, only the temperature increases. You will notice this. Repeat the same activity with sodium hydroxide, means base pellets, solids. Pellets means solids. Here too we find that the temperature has increased after the base and the water have mixed. So this proves to us that the process of dissolving an acid or a base in water is exothermic because heat is released. If it will become colder, that means heat was absorbed, we would have said endothermic. But here the heat beaker has become warmer, more hotter than in the beginning. So they are releasing, the process of mixing base with water and acid with water is releasing heat. So that's why we say exothermic. Okay, 39. While diluting an acid, why is it recommended that the acid should be added to the water and not water to the acid? We have discussed that, so you can read through them yourself. Why do HCl and HNO3, okay, etc. show acidic characters in water solution, while solutions like alcohol and glucose do not show acidic character? We have discussed that. Because this HCl, HNO3 release hydrogen ion, but glucose and alcohol cannot release hydrogen ion because they are covalent, they are not ionic. And then next 41, why does an aqueous solution of an acid conduct electricity? We have also discussed that. So go to the next question, 43. 42, why does the dry HCl gas not change the color of the dry blue litmus paper? That also we have discussed. How is the concentration of hydrogen ion H3O plus affected when a solution of an acid is diluted? Decreases. We discussed that also. All the rounded ones are discussed, okay? How is the concentration of hydroxide ion affected? 44. When excess base is dissolved in a solution of sodium hydroxide. That also discussed. So up to here is video 5. On Tuesday, you'll get video 6, and on Wednesday, okay, give a test. Huh?